Okay, well, this is part two of chapter two of the Rathus Introductory Psychology text. Welcome back. In the previous video, we looked at the sort of the micro perspective of the nervous system. We looked at nerve cells, looked at the various parts, the axons and the dendrites, the cell body, the myelin sheath, all that good stuff. And a simple moniker or simple mnemonic device I'd like for you to remember or use when thinking about nerve cells. Sorry, got a little choked up there. Is that axons speak and dendrites listen, if that helps you understand the difference between the two functions. So there's just a lot of terminology used. You can find easy ways to remember this stuff, the better. So this video will probably be a little bit shorter than the previous one and maybe even the next one after it, because we're going to look at the nervous system overall. We're going to look at the divisions of the nervous system and the different functions of those divisions. And I'm going to rely primarily on the slide you're seeing right now to describe the differences in the nervous system. So there are some slides afterwards that talk about the nervous system, but I might skip through those somewhat because I think I can, most of the important information can be described from this slide, which is figure 2.3 from the Rathus text. So let's take a look at the image here. We see, we have on the left-hand side, we have a scale a scale of our nervous system. So broadly speaking, we have the nervous system overall, and this encompasses, everything, includes, all your nerves, your brain, your spinal cord, all that stuff. But we break that down even further, and then we have the central nervous system, which is the brain and the spinal cord. Now, if we go over to the image on the right, I'm trying to move my arrow so you can see it. There it goes. Here's the brain, and here's the spinal cord. And notice that it goes right down the center of the human body. Kind of makes it easier to remember that the central nervous system is the brain and the spinal cord, right down the center. The central nervous system, down the center. I don't know, stuff like that is easier for me to remember. On the other hand, the other part of our nervous system is the peripheral nervous system. And this is all of the nerves throughout your body, all over your body, make up what is known as the peripheral nervous system. So, and if you look at this picture again, see all of these nerves extending from the spinal cord, they're on the periphery of the body. They're on the outer edges and the outside compared to the brain and spinal cords in the center. All the nerves are on the outside, the periphery. So maybe that helps. Maybe that'll help you remember the difference between those two. Now notice that the peripheral nervous system also breaks down again. It breaks down into two other parts, the somatic and the autonomic nervous system. And those two portions of the nervous system serve very different functions. The somatic, if you're familiar with Latin, soma means body. I think it's Latin or it's Greek. Someone's probably going to tell me otherwise. It's one or the other. I apologize if I'm wrong. But soma typically, I think it's Latin or Greek. One or the other means body. So we're talking about this is the part of the nervous system that controls the body, specifically the voluntary muscle movements. So the fact that you're able to take notes maybe as you're listening to me speak and you're able to follow along, the fact that your hand is moving as you either type or physically write notes, you're using your somatic nervous system. If maybe you pause this video in a few moments and get up to maybe go get a drink or go use the bathroom or something or another, again, you're using the somatic nervous system to get up and move around. This is all about voluntary muscle control. And notice how that portion of the nervous system yet again breaks down even further. We have afferent, efferent neurons, otherwise known as motor and sensory neurons, which we described in the previous video, which those two nerves sort of work together in combination for movement, sometimes voluntary, sometimes involuntary. Walking, getting up and choosing to move around is sort of a voluntary behavior, but maybe putting your hand on a hot object and pulling it away rather quickly is more involuntary. But both sort of involve these afferent, efferent, or motor and sensory neurons. So we go back over the peripheral nervous system. That's the somatic nervous system. Now the autonomic nervous system is, autonomic to me kind of sounds like the word automatic. And this is what we're dealing with. We're dealing with sort of autonomic muscle movement or automatic muscle movement. The muscle movement we really don't have a lot of control over. Those smooth muscle movements throughout your body, like your digestion and your heartbeat. I know there's things that we can do to influence those things, but you don't stop and directly control, how fast your heart beats or how your esophagus and your intestines and all those things digest food. They just kind of happen on their own, and thankfully so. If we had to sit there and think about all those things, that probably would make life a lot more difficult than it already is. So this autonomic nervous system, again, it's all about autonomic or automatic muscle movement, things that we really don't have a lot of control over. And like all things in the nervous system, it breaks down yet again to the sympathetic and parasympathetic nervous system. And these are very, very important for human survival. I think I talked about fight or flight, going into fight or flight in the previous video. And fight or flight is a state in which your body is literally preparing to either fight something or flee from whatever that thing is. So my example was maybe you're walking home one day, or you're walking in your neighborhood and you come across a big snarling dog. It's a stray dog. It's barking at you and it's big and ferocious, and you probably can feel yourself go into fight or flight. You can feel the hairs on your arms or neck stand up. You can feel your heartbeat increase. You can feel your, all of these things happening in your body. And again, it's a system that our body has over hundreds of thousands, if not millions of years developed to aid us in our survival. Because, there was a point in our time in human history where we did have to either fight things or flee from them for our own survival. Think about our early ancestors on the plains of Africa who come across a lion or some other large animal, and it was, I have to kill this thing to live or flee from it to live. Either way, I've got to do something. And that's kind of where these senses come from. And so that's part of the sympathetic nervous system. So, but there's fight or flight, and conversely, there's also rest and digest, which is the parasympathetic nervous system. Maybe once, that dog goes away, the dog is just walking around, it sees you, growls at you, and then runs off and goes somewhere else, and you've had a chance to calm down. Your body's now doing the opposite of fight or flight. Again, it's rest and digest. It's your body's natural way of calming itself down. And I want to make a note about this system of our nervous system that's really interesting. And again, fight or flight, the sympathetic nervous system, is very important for our survival. But the problem is we live in a world now where that mechanism of our body fires off at really any sort of stressor, not just, hey, there's this big animal that might bite me or attack me or whatever, a physical threat such as that. But we also, fight or flight also goes off when we, other things like, hey, oh crap, I went to class today and I didn't study for my test, and I'm really nervous about this test, or heck, if I even studied for it, sometimes I walk into class and I feel like, I'm stressed out. And so this fight or flight is very important for our survival, but we're now seeing that really when we are under chronic fight or flight, which is really known as chronic stress, that is has a very negative effect on our health. So anyways, we'll talk more about that, I think, in one of our later chapters on stress. So this will come up again, but I'm sort of prompting you to think about how this very important function at one point was so critical for our survival, but now not as important. It still is, but it's also part of our undoing, which I think is really fascinating. So kind of already talked about the somatic nervous system and the autonomic nervous system. I'm just kind of going through this and making sure I didn't miss anything, but it looks like we've already covered all of our bases here. Here is the sympathetic and parasympathetic at work. Again, we have on this side we have fight or flight. On this side we have rest and digest. So when you come across a barking dog, or maybe you walk into class one day and realize, oh, I've got to give a presentation and I'm totally unprepared. Your pupils might dilate. You might breathe more rapidly. Your heart rate accelerates. Your digestion sort of inhibits itself. And then conversely, maybe after you give the presentation and you figure out, oh, it wasn't so bad. I kind of winged it and it worked out. I got a good grade. All of the opposite things start to happen. Our pupils contract. Our breathing kind of slows down. Our heartbeat slows, et cetera, et cetera. Digestion resumes. So this is just a graph illustrating what's going on with fight or flight and rest and digest. So, truth or fiction? Check your comprehension. Fear can give you indigestion. What do you think? Go ahead and pause the video and come back whenever you think you have an answer. The answer is true. When we are in fight or flight, one of the things our bodies does is stops digestion, because really what's happening during fight or flight is the body is dedicating all of its resources to basically necessary functions, and in the moment digestion really isn't that necessary when you're trying to escape maybe a large predator or something at the time. That's not important. So oftentimes you may notice you may have an upset stomach or feel this feeling of indigestion when you're nervous or anxious. So not all that surprising. Again, central nervous system, we kind of already talked about that. Brain and spinal cord right down the center. So just again, I'm just kind of looking over this to make sure there's nothing important that I'm missing, but we've sort of briefly already covered that. We have white and gray matter, important parts of the spinal cord. One is myelinated, one is not. Maybe you've heard the saying, upgrade your gray matter, because one day it may matter. Maybe you haven't heard that, but it's a lyric from Deltron 3030, and it always makes me think of anytime we come across this section of the chapter. So both are really important. One is myelinated, one is not. So one is transmitting a little bit faster, information transmitting speed a little bit faster. In this graph 2.5, the reflex arc kind of shows you how all of this stuff comes together. Motor neurons, sensory neurons, white matter, gray matter, spinal cord, all of this stuff coming together. I mean, when we're talking about information processing, the doctor taps your knee, for example, and it relays that information up to the brain. The brain relays the information back down to the muscle, and you kick. And this happens so incredibly fast. We're talking about less than a second. I mean, it took me longer to describe the process than it would have taken that impulse to happen like 10, 20, 30 times, maybe. I don't know. I may be exaggerating, but it's so incredibly fast. It's a really fascinating process. Okay, we're going to stop here because we haven't talked about the brain yet. So I feel like this is a really interesting way we'll pause here. We'll come back and talk about the brain. So I guess think about this question or this statement, and we'll pause here. But the human brain is larger than any other animal. So truth or fiction. So we'll wrap up here, come back, and we're going to jump into the brain. The brain will probably be a longer video, so bear with me. Bring a snack or be prepared to take a break or two. But it's probably one of the more interesting sections, but it's also a lot to cover because there's a lot about the brain. It's that important of an organ. So anyways, this wraps up part 2, and I'll see you guys for part 3, you folks, for part 3.